Welcome to this lesson on similar polygons. This will be a fairly short lesson as it's just an extension of what we've been doing with ratios and proportions. You'll want to take a few notes down, these first two slides in particular, and I will ask you to pause this first slide and then the second one. So slide 1, slide 2. So now that you have that information down, we want to look at these two polygons. These are quadrilaterals, and as it says in the upper left corner, ABCD is similar to EFGH. We want to talk about what that means for those two polygons to be similar. The first thing that's going to happen, and I apologize in advance, this will not be very pretty, but the first thing that's going to happen is the corresponding angles are going to be congruent. So A is going to be congruent to E. Okay. Angle B is going to be congruent to angle F. Angle C is going to be congruent to angle G. What I'm doing is I'm not using a stylus, I'm using a trackpad. So I'm having to click and hold with another finger in order to make this work. That's why it doesn't look very good, but at least it's in Waukee Pride purple. So here we have the last angle D and H. Those two angles are congruent. Alright, so we have the corresponding angles being congruent. Well, what else is true is that the corresponding sides have to be proportional. So what we're talking about here is side AB, that side right there, has to be in a ratio with EF. So AB over EF has to be the same as BC over its corresponding side, FG. And then we would continue around the polygon so that all four ratios are the same, and that's creating the proportion that we want. So here's what it looks like. AB over EF equal to BC over FG. Those are the tops versus the rights. And then CD over GH, that is the two bottom sections. And then DA over HE, that's the two left sections. So all of those have the same ratio, creating a proportion. So it's, in order for these two polygons to be similar, their corresponding angles had to be congruent, and their corresponding sides had to be proportional. Now what I want to do is determine whether these two triangles are similar, and if they are, I want to write the similarity statement, stating exactly which two triangles are similar. So what I notice first is that I have two sets of angles that are congruent. Now I know that if my triangle is similar, I've got to have three. But because I have two angles in one triangle congruent to two angles in another triangle, I can recall my third angles theorem, which says that the third angles have to be congruent. Sorry about that. So our third angles right here have to be congruent. So now I've got that the three corresponding angles are congruent. Then the question is, are the three corresponding sides proportional? Well, you'd have to match up the correct sides. So, for example, if I have here the angle that has 3 arcs and the angle that has 2 arcs, I put the 3 arc to the 2 arc, V to O. I go over here and I find the one that matches that. Well, here's the 3 arc, here's the 2 arc. 3 arc to 2 arc is SE. So VO and SE are corresponding sides. Using that same method, I'm going to set up my proportion. It's going to look like this. It's going to say, is this true? VO over SE, is that equal to OL over EC, and is that equal to LV over CS? I would have to check and make sure that all three of those ratios are equal to each other in this proportion. So, taking the information directly from that, I'd plug in the values, and I have 4 over 18 equals 5 over 22 and a half equals 6 over 27. And again, I'm asking, is that true? Do I have the same ratio for all three corresponding sides? Well, if I was to reduce each one of these values, what I would get is a scale factor of 2/9. Now, using that, I can actually make a statement now about these two triangles because all the corresponding angles were congruent and the corresponding sides were all proportional. So I can state that VOL, that triangle, is similar, not congruent, but similar to triangle SEC. So again, this will be a little rough, but triangle VOL is similar, so we use our similar symbol there, to triangle SEC. And there we go. All right, moving on. Here we are told, we're not having to determine whether the triangles are similar, we are told they're similar. So given that, we want to find the values of x and y. So all we're really doing here is setting up proportions. Now we see that our left side of our smaller triangle has an x, the bottom side of our smaller triangle has a y, and then if this was a right triangle, then what we would call the hypotenuse is a number. Looking at the triangle on the right, the larger triangle, we have all numbers. So this will be easy to compare. We're definitely going to be able to get a scale factor. We need to establish our scale factor first, since the only two corresponding sides that actually have numbers are what would be, again, if this was a right triangle, the hypotenuse. Then we'll set up that as our scale factor. So the 15 on this triangle versus the 20 on this triangle. So our scale factor is 15 over 20, which you're going to want to reduce to save yourself a little work later to 3/4. Now we'll use that scale factor for everything because every corresponding set of sides should have that same scale factor since this is similar. So when I set up my proportion that x minus 2 over 12, I want to set that equal to 3/4. So there it is. X minus 2 over 12 equals 3/4. Now we just go back to what we did in our ratios and proportions section. We're going to use our cross product property. So I'm going to do x minus 2 times 4 equals 3 times 12. That's my setup. So the 4 times the x minus 2 equals the 3 times 12. A little bit of algebra 1 you guys should be able to handle by now. Gets you x equals 11. Now I go back and I want to compare the bottom side here, y plus 3 to 16. Well, y plus 3 over 16 should still have the same similarity ratio, so that's going to be equal to 3/4 as well. Doing the exact same thing, I'm going to take my y plus 3 over 16 equal to 3/4, and I'm going to use the cross product property. So y plus 3 times 4 equals 3 times 16. Again, little algebra 1 you guys should be able to handle, and we get that y is equal to 9. Again, fairly straightforward lesson. Just make sure you come to class with any questions, anything you still don't understand. Thanks for following the lesson today. Have a great day.